And now, without any further delay, let's begin today's Hexagon Geospatial webinar, UAV Data Processing and Storage on the Cloud. I'd like to introduce your first presenter for today. That is Dave Holmes. Dave, you have the floor.
Thank you, Phil. Good day, everybody. Welcome to our initial webcast series for 2016. We had quite a success and good participation last year, and so we're continuing these webcast series. We'll be doing these just about every 2 weeks through 2016. We're very excited with this initial topic. This is about UAV data processing and storage on the cloud. My name is Dave Holmes. I'll be your moderator today, and our principal speaker is Bruce Chaplin, who's one of our product line directors. As we've done in past webcast series, we'll limit this to 30 minutes, keep it very quick and very focused. Bruce will be doing an introduction to the topic for 10 or 12 minutes, and then he'll go into a demonstration for a little bit. And we do encourage you to submit questions in the question pane on the right-hand side, and we'll take a few minutes at the end and answer some of your questions. If you're not familiar with who we are Hexagon Geospatial, and our vision is to help you make sense of your dynamically changing world. As you bring in new data from different kinds of sensors, whether that be aerial or terrestrial sensors for imagery or new vector data, new human intelligence information, whatever the case may be, we provide software tools to enable you to capture that information, turn it into digital world models, and make some sense of it and take actions against that information. And of course, we all know the world doesn't change. You continue to get in new data maybe annually, maybe every week, everything in between. And our software allows you to see the changes, see the differences, understand the differences, and continue to make decisions using that information. We offer our products in two portfolio groups. The Power portfolio, which is our products that have been around for several years. We have three of those portfolio suites: the Producer Suite, our GeoMedia and Imagine products for authoring geospatial content; our Apollo Suite, or our Provider Suite, which is the Apollo product for managing and distributing geospatial content; and several products in our Platform Suite to enable you to build web-based and mobile-based geospatial solutions. And now this year, starting this month, we're really excited to introduce our new portfolio called the Map portfolio. This is part of our Smart Maps initiative, which is a new deployment model on the cloud for offering lightweight, very focused applications running out of the cloud for you in all different types of geospatial contexts. There are three basic components to it: the Map Foundation, which is the technology stack offering a lot of our technology into the cloud deployment model; the Map Studio, which is a development studio environment for building smart maps; and the Map Exchange for offering the smart maps from the cloud. Bruce will be talking about this world as part of today's presentation. So without further ado, let me turn it over to Bruce Chaplin, who will be giving our presentation on UAV data processing and storage on the cloud. Over to you, Bruce.
Thank you, Dave. As Dave mentioned, today we're going to be focusing on some new applications that have recently been released, and these are part of our Map portfolio. So the applications that you will see today they run on our Map Foundation, and they're available through our online marketplace, the Map Exchange. What I'd like to do, just to get us started, is talk a little bit about maps. Maps have been used for decades, centuries even, to depict geospatial, geographic information, to assist in navigation, and to model geographic phenomena. What I want to talk a little bit about, just to get us started, is what is the map of the future? The problem with maps is maps are static. And once maps have been created, they know that from the time they're updated, they become out of date, right? As the world changes around us, the maps are not updated. The content feeding the map may have been refreshed. And so very often the map effectively reflects what was. We believe the map of the future needs to reflect not only what was, but also what is, and what can and what will be. This means that the map of the future needs to be more dynamic, it needs to be fresh, it needs to be portable, and I think most importantly, it needs to provide answers. It needs to provide new insights. The map of the future for us is a dynamic information experience that helps to solve these problems. The map of the future is a Hexagon Smart Map, and Dave introduced the map portfolio. This is a new portfolio that we've just recently released that provides a complete environment, a complete ecosystem for our partners to design, to build, and to take to market smart map applications. So we spoke about this notion of a Hexagon Smart Map. Let's dissect that a little bit. What is a Hexagon Smart Map? Well, we start first and foremost with content. And as you know, we see an explosion in new content sources available in the market today. Obviously, we still have the traditional satellite vendors producing better and better imagery, higher and higher resolution, more spectral bands. But in addition to that, we have a whole new class of satellites available, the so-called microsats, which today promise refresh rates at unprecedented levels. Beyond that, we've got the UAV operators or UAV platforms now providing mapping on a much more localized level. And then, of course, there's the mobile data sources, mobile mapping and similar data sources, all contributing to this very rich and diverse set of content available to us. The problem with content, though, is that it requires additional processing in order to extract information. And so the second key ingredient for a Hexagon Smart Map is analytics. And so the Smart Map platform has an analytic engine that can be bound to content, allowing our users to extract information, to extract insights that allow and support decision making. In order to make this capability available to non-expert users, very often we need to model a business workflow. And so the third ingredient of the Hexagon Smart Map is workflow. And finally, it all needs to be presented in a way to the end user in a way that is accessible, digestible, and once again allows the user to draw insights and get answers from the application. So these are the four ingredients: content, analytics, workflow, and presentation. Characteristics of a Hexagon Smart Map: firstly, they are targeted. They're sort of moving away from general purpose heavyweight solutions to much lighter weight, targeted solutions that pinpoint and provide a solution to a unique business problem. And the dynamic nature I've already spoken about. So the first application we're going to talk about, and this is a core sort of building block of our UAV workflow. This is an application made available by Hexagon Geospatial called MapChest. MapChest is a content hosting application that allows our end users to store and manage geospatial data, provide data access, distribution of that data through a variety of different web services like WebMap service, so-called WMS, WebMap tile services, WMTS, all safely and securely and operate in a cloud environment. MapChest you can think of a little like a geospatial Dropbox. It accepts multi-source input from imagery, feature data, flat file, feature data, point clouds, video data, as well as other business documents, spreadsheets, Word documents, PDF, and so on. All able to be uploaded into the cloud, indexed, metadata, described, and so on, and then made available to an audience of users, internal, external, as a service. Again, web mapping service, WMS, other services, a download service, which allows you to make the data available through enterprise workflows into browser-based applications, WebGIS applications, or mobile platforms. So with that, let's sort of move into what we see in terms of unmanned aerial vehicles or unmanned aerial systems. Obviously, this is technology that has exploded onto the scene at various levels. I mean, you can go out to Amazon and other vendors and purchase consumer-level unmanned aerial vehicle platforms, all the way up to high-end prosumer or professional-level platforms that are now being used more and more to capture data in challenging areas that may be unsafe for humans. It allows us to provide, obviously, much highly localized mapping solutions, getting much faster from data capture to actionable information, and a whole new class of rapid mapping applications are now more accessible to a greater class of users. The problem, though, although the data collection itself has become easier and easier, is that the data processing can still be complex. Traditional photogrammetric workflows typically require fairly specialized knowledge, fairly specialized software. They can be intensive, manual intensive, and the turnaround time can often be slow. Once the data has been processed, it can also be then difficult to distribute, make your content available, make the results available to your end user. So we need a better solution. The industry needs a better solution. And so what we need is the ability to simply and rapidly process and disseminate results that matches how quickly, how easily we can collect imagery data on a UAV or UAS platform. So our partner GeoSystems Germany, based in Europe, based in Germany, have built what's called the Geo.App.UAS. This is a cloud-based application. It's designed and built by GeoSystems Germany to run on the Smart Map platform. It offers a streamlined workflow enabling robust photogrammetric processing of data on the cloud. It's used in conjunction with the MapChest application that I just mentioned to manage data from sensor through processing and ultimately to usable product. So from data collection, typical workflow, we upload using MapChest. You can see here the UAV cloud solution runs on Amazon Web Services. This is the hosting platform for the Map Foundation. And like MapChest, the Geo.App.UAS is now available through our online marketplace, the Map Exchange. And once processed, again, using MapChest to deliver content as a service. So how does it work? I spoke a minute ago just about how complex traditional photogrammetric processing can be. What GeoSystems Germany have strived to do is to make the workflow really as simple and accessible as possible. So with just 7 steps, effectively, you can accomplish end-to-end processing of data collected on a UAV platform. So once the data has been collected, the first step, as I mentioned, is upload data with MapChest. So now your data is in the cloud. It's accessible to any other applications that are running on the Smart Map platform. Launch and log into the Geo.App.UAS. All of the applications are secured. You require credentials to log in and use the applications. And the first step is just select the data that you would like to operate on. In this case, Geo.App.UAS connects to your MapChest folder. MapChest account allows you to browse your data holdings and select the data set that you would like to process. You then specify your processing options, inputs, outputs, some parameters, and then effectively run the process. At this stage, the processing is completely hands-off. You're able to log out of your account, walk away if you wish, and the processing continues on the cloud until completion. At some later time, you can log in again and view your mosaic, your surface model, your shaded relief online from whichever machine you happen to log into. From that, again, through your MapChest account, you're able to download and share the data with other users. A few of the key features, it does work with any fixed wing or rotary drone UAV platform. It allows, along with that, easily handling of orientation data. Most of the UAV providers or sensor providers have their own format, of orientation data. And so Geo.App.UAS will allow flexible ingest of different orientation parameters. So what GeoSystems Germany have tried to do, and I believe have succeeded, is provide an easy-to-use end-to-end workflow that allows end users to upload, store, process, and share their UAV content, UAV data. So with that, let's move into a quick demonstration. I'd like to show you a little bit about how these look. So I'm going to go ahead and share my screen. And so I have my browser open, and I've navigated here to the Hexagon Geospatial online marketplace. This is the so-called Map Exchange. And you can see here both MapChest and the Geo.App.UAS are available in the Map Exchange. You can see up in the top right here, I am logged in as myself. And so what I'm going to do is navigate over to the My Apps tab. And in the My Apps tab, you can see what applications I currently have available to me. So I'm going to launch the MapChest application. You can see it's now started a new tab in my browser. And it's basically brought me to my MapChest account. These are my data holdings for the most part. Everything you see in front of you here is basically a folder, but within I'm able to navigate into certain folders and see different data sets that have been uploaded prior to today. I have a few tabs on the left-hand side which allow me to filter different data sets. I can also, on a data set by data set basis, view some of the properties available with the content. So when was the registration date? What folder does it reside in? You know, what document? What data set type is it? What's the file name? So on. And along with that, there's a number of actions that I'm able to execute on each data set. So you can see I can share it, I can download it, I can delete it, and so on. The last tab here is a task management tab. So as soon as I do anything in MapChest, typically that runs as a task. If I run an upload, that's going to create an upload job, upload task, and I'll receive a little notification here as it uploads the data. So if we were to start off our workflow, the first thing I would do typically is to create a new folder. So it's now created. You can see my little notification down in the right, new folder successfully created. And if I were to then upload some data, I would select the upload action. And I've got two options. The first option, I can just select add files. It'll open up a file chooser, allow me to select some data to upload. What I'm going to do is I've already navigated to a folder that has some data in it. If I were to select some of the data, drag and drop it, it then adds it basically down in the list, ready to upload. The next step basically would be to hit the upload button, and that effectively would start an upload. What would happen in that case is data is pushed up into the cloud. It's received by MapChest sort of back end. It's placed into my data repository, and what we do is actually extract automatically some of the metadata from the files themselves and register the data in a catalog. So we effectively have a catalog that maintains metadata and keeps track of all of my data assets in my MapChest account. Everything is secured, which means that only I am able to access my data unless I choose to make it available to somebody else, either through sharing it within my organization or by publishing it as a service. So this is probably, what is it, around 77 megabytes. Rather than go through and watch the data uploading, I'm going to cancel out of that and come over here, and it's basically the same data set that I had shown beforehand. So once the data is uploaded, the next step would basically be to launch our Geo.App.UAS. And so you notice there I went back to the Map Exchange, my My Apps tab. I've launched the Geo.App.UAS, and you can see I've got three main actions that I can take at this point. One is to start processing UAV data. The second is to view my jobs, and the third is to display some of the created outputs. You can see up on the top right-hand side here, I'm still logged in as Bruce Chaplin. This means that as I moved across different applications within the Map Exchange, the single sign-on transfers my credentials over application to application. So if we were to set up a data set to start processing here, the first step, as I mentioned, is to select your data set. And if I select that, you can see it is now connecting to my MapChest account. And so I'm going to select the UAS Webcast folder. This is where I previously uploaded the content, and you can see that it lists the data sets that I have available. There's 15 files. If I select this folder, it displays the same set of thumbnails for me that we viewed previously in MapChest. So if I hit Next, now I need to basically go through and specify what output products I would like. And you can see I've got a couple of different format options, TIFF, IMG, ECW, and JPEG 2000. What I'm going to do is basically select a different output folder, and I'm going to call it Demo Mosaic. Here I'll call it a Demo DSM, check the file, select it, and finally I will call it Demo LAS, check the file, and accept it. So you can see here there's basically three main products, data products, that I can produce from my UAV workflow. The first is a mosaic. So effectively what will happen is it will take all of the individual images, it will stitch them together using photogrammetric processing techniques, perform the so-called georeferencing. Once that's done, it effectively then does a mosaic, produce an orthomosaic. So from all of my individual input images, I will receive one mosaic output image. Along with that, I also will produce a digital surface model and an LAS, a point cloud, extracted from the resulting mosaic and stored in the LAS format. Once I do that, it gives me a summary of my result, of my parameters, and then effectively it says Start. So at this point, I can hit Process. You can see UAV has successfully started. What it's doing now effectively is provisioning a processing engine, if you will, in the cloud on Amazon. This is running on our platform along with GeoSystems Germany UAV processing application. It's firing up an engine. It's making the data available to it, and it will start cranking away, basically producing it. Runs as a black box, as I mentioned earlier. At this point, I could log out, go off and do something else, and come back at a later time. So this can take a little while to process, running through all of the point extraction, the georeferencing, the triangulation, ultimately getting to producing a mosaic image along with the additional products that I mentioned. So what we'll do for now is we'll look at the one that I processed yesterday, to get an idea of what the results look like. Once the processing is complete, it actually publishes the results back to MapChest. And so what you'll see here in a minute is as I open up a preview, it's loading the results, and effectively what it's doing here is it's accessing my resulting mosaic from my UAV processing as a service. It's now displaying the mosaic as a web map service in a little preview window. I'm going to zoom out just a little bit just to kind of give you a feel for where we are. So you can see we're in Germany, nearby Munich. This is near the home office of GeoSystems Germany. So if I zoom back in here, you can see this is a fairly small data set. It basically covers a construction site a gravel pit in this vicinity. What I'm going to do is zoom in here, and just to give you a feel for the quality of the resulting triangulation and mosaicing. You know, it's interesting to note, as you saw, we ran it basically without ground control. We effectively only had the so-called EXIF tags, the geotagging tags, off of the sensor. And the mosaic is of good quality. We don't see any real shearing effects, and so on. I'll just move around here a little bit. Again, this is accessing the resulting image as a service, a web map service, and I'm consuming it in my browser. Some of the other data types, I mentioned the digital surface model. What's now possible is to actually take the mosaic and the surface model and use that for some downstream additional analysis, things like volumetrics, either consuming the image into a desktop application like EarthAT Imagine to do volumetric calculations, or to do downstream analysis in other applications, either web-based or desktop. So this is still moving along. So this is Geo.App.UAS, again in combination with MapChest, and this application provides an end-to-end workflow that allows a very simple, elegant way to upload, process, catalog, and then disseminate results from your UAV workflow. Both of these applications are now available in our Map Exchange. Very simple pricing models. Typically, both of them are available as a monthly subscription. You pay month to month. There's no long-term commitment, and basically we have a tiered pricing structure, which means that you can effectively get started on MapChest in combination with GeoApp for as little as $99 a month. We have a number of users that are now have some very interesting applications using this in downstream value add products. So with that, David, I'll pass it back to you.
Great. Thank you very much, Bruce. Excellent job. That looks fantastic. So we'll move on to wrapping up the webcast, and we'll take a few minutes and answer some of the questions that are coming in. We appreciate that. Just a couple of items we want to touch on. One is polling questions. These will show up on the right-hand side of your webcast pane. What topics would you like to see covered in our webcast series? We're always interested in hearing your thoughts, and we do take those into consideration in planning our webcast. And are you interested in pricing for any of our Hexagon Geospatial products? And you see on there included now the two that Bruce just presented, the MapChest product and the Geo.App.UAS product. You can get quite a bit of information on our products, on e-training on a lot of our products, and also video demonstrations off of our website. And I've provided some links that you can follow up with. We also have the Hexagon Geospatial YouTube channel now with quite a bit of video demonstration content available for you to have a look. To learn a little bit more about smart maps, and in particular MapChest and the Geo.App.UAS, visit our website. There is a landing page called Smart Map right off of our front page, and since we're launching Smart Maps this month, you'll see quite a bit of content on our opening Hexagon Geospatial webpage. And I'd like to introduce the Ignite program. This is a part of our launching program. This is a program to encourage people to build smart maps. It'll run this year with to begin with people submitting ideas on smart maps that could be built. There'll be 20 finalists selected at our user group meeting in June, and those 20 group people will go off and build a smart map and submit them into a competition. These will be judged, and we will be awarding over $250,000 to a few winners of the Ignite program, with the first place award of $100,000. Those winners will be announced in December. So I encourage you, if you are interested in exploring the world of smart maps, to take a look at this, and you can find information on this on our webpage. Our webcast schedule, we have webcasts laid out for the next 4 or 5 months, and as I mentioned, we'll be doing these every couple of weeks, although in January we are doing 3. Next week's title is Maximize Your Imagery and LiDAR Investment with ERDOS, Apollo, and Imagine. That'll be next Thursday at the same time. We also have all of the webcast series that we presented last year. We have those recorded and available at this same landing page. You can find that off of our Hexagon Geospatial website. So with that in mind, let's take a look at some of the questions that have come in. We appreciate some of these folks bringing these in. We've got quite a few here. I'm just going to pick one or two because we are running short on time. One, Bruce, why don't you start with this one? How long does it take to process UAV imagery, please?
So the answer, unfortunately, Dave and Penny's is it depends. It really depends on a number of factors, ranging from everywhere from, partly how many images you have as input, what is the resolution, how much data are we dealing with, and then what output products do you select. So obviously the basic, we'll say the minimum output product we have right now is the mosaic, to produce a mosaic. But if you go a step further and actually produce a surface model or a point cloud from the imagery, from the results, that is additional processing. I'll give you an example. The one that we ran, that we just ran this morning, it's not very big. It was, I think, 15 or so images, around 80 megabytes or so. That probably runs in around 7 minutes or so. We've got other data sets, obviously up to 100 images, may take, an hour or so. We have run some projects that have taken up to, 24 hours even. All runs silently in the cloud, and you log in the next day and your results are there.
Good. Another question, where does the information for the digital surface model come from?
It's extracted from the imagery, if I understand the question correctly. So once you've done, you have all these individual images, and I don't know how much you understand about photogrammetry, but we have all the individual images. We run basically what's called a triangulation, which is georeferencing. And following that, all the imagery is georeferenced, and we're able to mosaic them. Once we mosaic them, we have a single image. Because we have now got georeferenced imagery with stereo overlap, we can go back and basically do image correlation to extract the surface model.
Okay. One last question. Does the subscription model that you talked about, does that include orthomosaics, point clouds, and surface models?
It does indeed, correct. So the model, the pricing model for MapChest is basically based on how much storage you would like, and the pricing model for the Geo.App.UAS is basically based on how much processing time you would like. So if you're a heavy, UAV operator that's working, daily, you would go for a plan that allowed you, many hours, 100, 200 hours of processing time per month. If you're a more casual user, we got plans that start as low as 10 hours per month.
Excellent. Folks, several of you have sent in some really good questions. We are out of time. What we will do is we will come back to each of you individually by email and get an answer to your question. We really appreciate the interest in today's webcast. I have put on the screen a point of contact for you, Mr. Justin Bird. He is our inside sales manager. And so if you have some follow-up, he would be a good one with his email there listed on the screen. And of course, this webcast has been recorded and will be posted on our website under the webcast series within a day or two, so you could go back and watch this again at your leisure. Listen, we thank you very much for taking the time today to attend our webcast, and we look forward to seeing you in future webcasts. Have a great day.